Earth is already silent. The forests are gone. The giant bodies that once moved through them are gone. The sky above the planet looks calm, but that calm is only the last frame of a disaster that began with one object falling out of space. Rewind the silence. A bright line crosses the upper atmosphere at impossible speed. It does not drift. It does not burn slowly over the horizon. It arrives like a piece of daylight sharpened into a weapon. Below it lies a shallow sea over what is now the Yucatán Peninsula. The surface still looks like a world with time left. There are coastlines, forests, rivers, nesting grounds, warm air, and animals moving through a planet that seems stable. Then the window closes. The asteroid strikes. In the first minute, the impact does not behave like an ordinary explosion. Rock is punched downward. The crust rebounds upward. A crater wider than a modern city opens in the earth, and the seafloor becomes a violent mixture of melted stone, shattered minerals, and vaporized rock. From far away, it would be easy to believe this is the disaster itself. A local wound, a point on the map, a place where everything nearby ends. But the collision has done something more dangerous. It has launched consequences that have not yet arrived. The asteroid is no longer just a rock from space. It is now a clock. Every piece of material thrown upward, every shock wave driven into the crust, every cloud of vaporized, sulfur-rich rock has begun moving along a path that life below cannot stop. The first escape route disappears before most of the planet even sees the sky change. The ground begins to carry the message. Seismic waves race outward through the Earth. They move faster than the atmospheric blast and faster than the falling debris. Continents far from the impact are shaken by a force that does not need the crater to be visible. Thousands of kilometers away, inland water begins to move in ways it should not. Rivers and channels surge. Mud rises. Fish are lifted, thrown, buried, and trapped inside a chaotic layer of sand and silt. Only later does the proof become visible. At Tanis, in what is now North Dakota, fossil fish preserve this moment with brutal clarity. Their gills contain tiny impact spherules, glass beads made from rock melted by the collision and thrown into the sky. That detail breaks the safe assumption. This was not a Gulf disaster with distant witnesses. Before the glass beads fully settled from above, the planet itself had already shaken water systems far from the crater into violence. Distance had not saved anything. It had only delayed understanding. For a little while, the sky may still seem like the remaining refuge. The direct blast cannot cross every ocean. The crater cannot physically crush every forest. A living thing far from the Yucatán might survive the first shaking and still appear to be standing inside a familiar world. Then the asteroid returns in another form. Above the atmosphere, molten droplets of Earth's own crust arc back from space. They are small enough to look harmless in the hand, but they are not arriving one by one. Billions of them begin falling across the planet. The air itself becomes part of the impact. As the spherules re-enter, friction heats the upper atmosphere. The sky no longer protects the surface from space. It radiates heat downward. The danger is no longer only underfoot, and it is no longer only near the crater. The shrinking window is now overhead. Forests do not need to be struck by the asteroid to enter the disaster. Vegetation dries under the thermal pulse. Fires begin across wide regions. Smoke rises into an atmosphere already loaded with pulverized rock, sulfur compounds, and the returning dust of the impact. The visible world changes again. The asteroid is no longer a falling object. It is a rain of glass. It is heat arriving from above. It is the sky becoming hostile to life that had survived the ground. And yet, even this is not the final mechanism. Fire looks like an ending because it is visible. Flames move, animals flee, smoke darkens the horizon. A viewer can understand burning immediately. But the more dangerous consequence is quieter. The asteroid struck a shallow seafloor rich in sulfate-bearing rock. The impact vaporized enormous amounts of that material and drove it high into the atmosphere. There, sulfur-rich aerosols began spreading into a reflective veil. The planet still has a sun, but sunlight can no longer reach the surface in the same way. That is the contradiction that makes recovery fail. After many disasters, the violence weakens and life begins to return. Here, the first day has already arranged the next catastrophe. The atmosphere has become a filter between Earth and the energy source that feeds its living systems. Plants cannot respond to a darkened sky by running. Photosynthesis begins to fail. Primary production drops. Food webs lose their base. The animals that survived the blast, the shaking, the heated sky, and the fires now face a planet where the conditions for feeding are disappearing. The extinction is not completed in a single day. That matters. Not every dinosaur falls when the asteroid hits. Not every ecosystem dies in the first hours. But the first hours lock the system onto a path. The remaining deaths unfold through the consequences already set in motion. Darkness, cooling, acid rain, ingredients, collapsing food chains, and a world no longer able to sustain the giant life it held before. The disaster has changed scale for the final time. It began as a collision. It became a planetary systems failure. Long after the sky stops glowing, the evidence remains. In rocks around the world, a thin boundary marks the divide. Below it lies the last record of the Cretaceous world. Above it lies a different Earth. Inside that boundary are the traces of the asteroid's return impact material, altered glass, and the chemical signature of a day when the planet's connected systems turned one event into a global transformation. The asteroid is no longer visible in the sky. It is in the stone. A thin layer holds the memory of the moment when the old world lost its remaining chances, not because one rock crushed everything at once, but because one impact changed the ground, the water, the atmosphere, the sunlight, and the food beneath every living thing. The countdown ends there. At the boundary between two Earths,